Assalamualaikum and very good morning. Today we are doing lab 4, that is force convection. Today I will explain about the how to set the apparatus. First of all, we will open the power supply. Okay, that is the power supply, and now we are doing fin. Okay, fin. So based on the screen, we will set the airflow that is 3.0 until reach 3.0 meter per second. Okay, airflow we will wait. So we set the power until 30 watt first. Okay, wait until the screen stable. Okay, so we will open the button and then we will adjust the airflow and the power. So the airflow adjust until reach 3.0. Power. Okay, so the power we will adjust until reach 30 watt. Okay, that's all from me. Thank you.
After we have set the airflow and the power, which is 3 meter per second and 30 watt, then we wait for 10 minutes for the temperature to stabilize. After the temperature has stabilized, we can use this probe to record the temperature. Firstly, we use the first hole, which is the nearest. Insert it like this. Then record the temperature at T3. This is the first hole. And then we select the magnetic cover to record the rest of the hole. But to record for each hole, we need to wait at least 1 minute for temperature to stabilize. It means after you record the first hole temperature and then you wait 1 minute, then you can record the next hole temperature.
Okay, after we are done with the fin, we are going to replace it with this very nice pin. Okay, firstly, shut this down.
Switch out bawah.
Okay, then we take off this. After connecting the socket, we are going to adjust the airflow into 3 meter per second and the power into 30 watt. And after we adjust the power into 30 watt, we are going to wait for at least 10 minutes in order for the temperature to stabilize. So right now, I'm going to adjust the airflow. Okay, now we wait for 10 minutes.
After we set the airflow and power, we collect the data with this probe. This probe we attach to the pin for the first hole and wait for 1 minute to stabilize. After we take the data and we replace the hole to second one. We repeat until hole number 6. After we collect the data, we have to shut down the machine. We switch on the main power heater and the main power supply. That's all from me. Thank you.
Assalamualaikum. My name is MOHAMMAD HAMYZAN bin ADNAN, and I will discuss the results of force convection with pin surface. So the power output that we use is 30 watt, and the air velocity is set to 3 meter per second. And from the table, we can see that when the probe position is changed, meaning that the distance increase, the surface temperature also increase, and the highest temperature that we recorded is 42.7 degrees. So as a result, when the surface temperature increase, the difference in temperature also increase, and the highest difference temperature is 5.3 degrees. Next is force convection with thin surface. Power output is still the same as long as the air velocity, which is 3 meter per second. So the result is quite the same. The surface temperature increase when we change the probe position, and highest surface temperature is 53.8 degree, and the highest temperature difference is 5.4 degree.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad bin RAHMAN, and I will be explaining the discussion part. So for the first question is we need to create a chart of temperature against probe position along the pin or film. So this first graph is the pin surface for force convection. This is the graph for pin surface force convection, and this is the graph for pin surface for free convection. As we can see, all of the graph is directly proportional. So for the next question, we need to calculate and compare the difference in gradient between the free and forced convection for each surface. So to calculate the gradient, in the graph we need to pick 2 points, and then we use the formula m equal to y2 minus y1 divided by x2 minus by x1. So for pin surface free convection, we get the gradient 0.847x minus 2.71. Gradient for pin surface, y equal to 0.11x plus 4.604. And then the gradient for pin surface post convection is y equal to 0.115x plus 4.03. So for comparison of the gradient, all of the graphs show positive correlation. For pin surface, you can see that it has the higher gradient compared to fin surface. Next, the fin surface has the highest y-intercept value. The reason why the fin surface graph has the lowest gradient is because this shows that fin surface are able to spread the heat evenly along the extended surface. And lastly, fin surface free convection has the highest gradient because it is affected by the power input. That's all from me. Thank you.
Assalamualaikum and very good morning. I'm AMIR bin MOHAMMAD ADNAN, and today I will explain the discussion number 3 on force convection. So what can you say about the difference? Which type of convection gives better spread of temperature along the extended surface? So the difference shows that the fin surface has a higher temperature difference between the probe temperature and the inlet temperature. This means that the fin surface is capable of absorbing more heat to its surface. This proves that fin surface gives better spread of temperature along the extended surface. So number 4, the answer is the question is the extended surface is made of stainless steel, which is relatively poor the conductor. How would using aluminium or copper better conduct affect the temperature gradient and the overall efficiency? So the answer is aluminium and copper has a higher thermal conductivity compared to the stainless steel. That means the aluminium and copper is more better than the stainless steel. This means aluminium and copper can be conduct heat better than stainless steel. So by using a better conductor, it can affect the gradient so that it become less tapped, as it can transfer more heat easily, thus increasing the overall efficiency of the material. That's all for me. Thank you.
The conclusion for this experiment is the fine surface is capable of dissipating more heat. Number 2 is as the gradient become less steep, the temperature difference will be increased. Number 3 is the temperature along the extended surface is consistent through a convection process. Number 4 is surface area and thermal conductivity of material can be affect the graph gradient. Number 5 is by forcing the convection process, which in this experiment we had used a blower fan. It helps to reduce the graph radius. That's all for me. Thank you.